This video, I'll talk about density, temperature, and buoyancy. All right, before we begin, let's talk a little bit about energy transfer. From previous lessons, you learned that there were three types of energy transfer: conduction, convection, and radiation. Conduction is when two objects touch and the energy transfer directly from one object to the other. Radiation occurs when heat is transferred through empty space by electromagnetic waves. So you can think of as the sun, you can think of a light bulb, so it's light, it's transferred by light. And then convection occurs when heat is transferred from one place to another by fluids. Okay? And the whole purpose of us talking about density and buoyancy is so we can better understand convection. The one important point to highlight here is that fluid is not the same thing as liquid. Okay? Anything that flows is considered to be a fluid. For example, air, liquids, right, like water, as well as really hot molten metals or molten rocks. So anything that can flow is a fluid. So let's begin talking about density. So we start with those two cases of these two boulders over here. One is real and the other one is fake. Okay. The one over here can be lifted, the other one, there's this guy here lifting it. Obviously, they're not made out of the same thing. This is the real boulder. They're both the same size. Notice they're the same size, but they're made out of different things. One is more dense, it's tightly packed, and weighs, what, 300 kilograms? While the other one is less dense, it's more loosely packed, and will only weigh 10 grams. Okay, so when we talk about density, we're looking at how compact something is. I also want to show this graphic organizer because I'll be talking a lot about weight and mass and volume. So here's the definitions. Weight is the force of gravity on an object, where mass is the amount of matter that something has. Okay. Volume is how much three-dimensional space something occupies. You can think of it as the size. Density is how tightly packed atoms are. Okay, so those are the definitions. We calculate density by measuring mass and volume and calculating its ratio. So density is a ratio of how much matter something has with how much space it occupies. So how tightly packed something is. So here's an example. We have two objects here, and pretend that those are atoms. We have two objects here. They're the same size, so they have the same volume. However, one has way more green dots than the other one. That means that this one is more tightly packed, therefore more dense, where this one is less dense. Okay. Let's look at another example. Okay, so now we have four different atoms, or four different objects. Looking at A, B, and D, we can see that they have the same volume. Okay. A is obviously less dense than B and D. Right, so now it becomes B and D. If you count, D has way more matter than B. So in that case, D would be the most dense because it just has more matter than B. Okay, so far we have D as the most dense, followed by B, followed by A. But now let's look at C versus A. They both have the same number of dots, 5 and 5. However, look over here, C has way greater volume. Therefore, the atoms are not as tightly packed. So C would be the least dense. Okay, so let me try to write that down. So least dense, followed by A. Okay, followed by A. So this, we say this one's 1, least dense, followed by A, followed by B. So let me put 3, followed by D. Okay, so in terms of density, this is the lowest, followed by this one, followed by this one, followed by this one. okay? Because we need to look at size, as well as the number of dots or the amount of matter that something occupies. Okay, and that's how we define density. Right, next slide. I need to actually stop this. Okay. But we cannot see inside of an atom to know how much matter, inside of a molecule to see how much matter it occupies, right? That's impossible. We can't, looking at a glass of water, you cannot see individual water molecules. They're too small. So the way we do this is we measure mass by measuring weight, and we measure volume in a couple different ways. So let's first look at this example over here. So you have this steel cube, okay, that has a mass of 7.8. I know it's kind of small. It has a mass of, let me get my pen again. It has a mass of 7.8. It has a volume of 1 ml or 1 centimeter cube. So if I calculate the length, or the length with the height and the width, right, I get 1 centimeter cube. That's how that was calculated. And here I have a nail that has a mass of 12.5 and a volume of 1.6 mLs. So if I'm going to do this calculation, all I need to do D equals 7.8. So I'm using my mouse to write this. It's kind of tough. Divided by 1.0. Okay, and in here I take D is 12.5 divided by 1.6. And if I divide it here, let's see what we get. For this one, obviously the density is 1.8 grams. I'm just keeping the units per, I'm just going to say mLs or centimeter cubes. In here, let me use my calculator. I got 12.5 divided by 1.6, and I get 7.81. And I'll put it over here, grams per ml or centimeter cube, same thing. Okay, so the nail is slightly denser, greater density, right? Slightly denser than the steel cube. That's how you would know. And I just took this number and divided by this number to get that. All right, let me erase this. All right, measuring volume. There's a couple ways. I said there were a couple ways to measure volume. This one, you just measure the 3 dimensions and just multiply it, just like you would do in your math class, right? You just take the width, the height, and the length, and you multiply them, and you get your centimeter cube. For liquids, that is equivalent to mLs or milliliters. But what happens to this nail? I can't do that to the nail because the object is not uniform. For cubes and spheres, you can. But for objects that are not uniform, their shape is not uniform, you have to do something else. And that something else is called water displacement method. Okay? In order to do that, we need a couple things. We need to use some sort of measuring device where in lab we call a graduated cylinder, where each of those numbers here represent mLs or milliliters. You need to remember for water, because we're doing the water displacement, 1 milliliters equals 1 centimeter cube. So say I want to find out the volume of this toy dinosaur here. Okay, what I need to do is get volume initial. Okay, and the volume initial is, let's see, this is 1 ml, 2 mLs, 3 mLs, 4 mLs, and then 4.2, 4.4, 4.6, 4.8. Okay, right here it's 4.8. So the initial volume is 4.8 mLs. Okay. And then I stick the dinosaur inside, and just like when you get in a bathtub, the water of the bathtub rises up because you're just placing that water with your body. The same thing, the dinosaur is going to displace the water with its body. So the final volume is going to be 5, 5.2, 5.4, 5.6, 5.6. Okay, so then the volume of the dinosaur is going to be, let's see, a minus 2 is 2. Okay, actually I should do it backwards. Hold on 1 second. Let's just do instead of having to do this way. So you do 5.6 minus 4.8, and you get, erase this, never mind. You get the volume of 0.8 mLs, okay, or centimeter cubes. So the volume of the dinosaur is 4.8 centimeter cubes. Okay, that's how much water was displaced. All right, let's erase. All right, so then let's talk about buoyancy. And here's how we define buoyancy: is the upward lifting force that acts on an object when it pushes aside a fluid. Okay, we just talked about pushing aside a fluid. This is where we're going. So when you take a rock and you throw a rock down the water, you're going to notice that the water is going to sink, or the rock is going to sink, when it's going to sink by displacing the water that was dropped in. Okay. Now here's an interesting thought. A rock is much lighter than a boat, and yet this rock sinks, whereas this giant boat floats. Okay, so then the weight of an object is not enough to tell whether something will sink or float. Density should be used instead. So when you think about something sinking or floating, you have to think of the density of the object versus the density of the fluid that's in. Because there are two forces that are playing here. One is gravity, that's pushing everything down. The other one is buoyancy, which is the force exerted by the water. Right? It's the force that's being exerted by the water. I just put force of water. Okay? Because for the water to be displaced, it requires work. It requires work for the water to be pushed aside. So only objects that have a high enough weight can push it down. Okay, so it's going to be a combination of the weight or mass, and it's going to be a combination of how much of what is being displaced, which is volume, and we know that that's density. So let me erase it. All right, and that's why it is so difficult. I don't know if you ever tried. It is so difficult to try to sink a large ball, a beach ball. The reason for that is because its weight is very small in relation to its size. Okay, if you try to reach it, it's extremely hard because again, its weight is very small relative to its size. So there's two basic rules for you to know if something will sink or float. If something is less dense than the fluid it's in, it will float. Oops, let me erase that. Okay, so let's try it again. If something is less dense than the fluid it's in, it will float. If something is more dense, then the fluid that's in is going to sink. So the beach ball obviously is less dense than the water, okay, based on that rule. In our other example, the boat is less dense than the water. The rock is more dense than the water. Okay, so using that, you can compare whether something will sink or float. The last topic that we need to talk about is how heat affects density. Because we know when we heat something up, we cause molecules to move way faster, or particles to move faster. How does it affect density? Here's an example of cold air moving very slowly. Here's an example of hot air So hot air moves faster, so it takes up more space. Okay, so it becomes less dense. So hot air is usually less dense than cold air. Okay, that explains why hot air rises. Because hot air is less dense than cold air, so it rises up or it floats. Right? We just talked about how something less dense in the fluid will float. We can think of hot air rising as hot air floating up. A very common example is a hot air balloon. So let me walk you through it. So the air inside is the same. It's air. Okay, it's a mixture of gases. Okay, that's, well, technically slightly different, but let's just say it's the same air. When you light the hot air balloon, you start heating up the air particles inside, so they take up more space. And when they take up more space, they become less dense than the cooler air outside. Because they become less dense, they float because everything around them is more dense. Okay, so that's the idea behind. And that's the idea behind when you begin to study convection and convection currents. Let me erase that. There is a link under your notes which has a PDF of a textbook that explains all of that I just explained. So if you want to read it again or read it, if you want to extend your knowledge, you can go there as well. That's it. Let me know if you have any questions.